Hello.
Huh.
Tell me some cool flat earth shit.
What?
As what do you class as cool flat Earth shit?
I want some of the really compelling stuff. Some of the stuff that an anti-flat earther would say, I can't deny this, but I still think it's a globe.
Well, that's pretty
Well, that's
silly logic, yeah, because anti-flat Earthers not going to agree with anything because they're dishonest. They have an agenda.
Oh, what do they say about the oil rigs?
like you already know this stuff, man. I don't. Why are you asking
Yeah,
these questions? You already know.
well, yeah, but I'm saying, do you have any other stuff like the oil rigs?
Yeah,
we
man,
had
we
a
got tons.
discussion, you and I, the other night about everybody's experience, everybody in every industry measuring the Earth as flat and treating it that way and referencing it that way. And now you're back pretending like you didn't hear any of that. And I'm wondering if you're trying to treat us like some kind of singing, dancing monkey that you can just ask to tell you things. Kind of disrespectful.
Well, I was just coming to a group of people that know more about it than I do and asking for the good stuff.
In the
Like
words of
I don't
Jimmy,
I don't want to hear
in the
like the
words of
oil rig
Jimmy,
stuff
it sounds
again
like he
because I've
had a
already heard that.
full NPC reset.
Who cares? We got an audience. Do some exposition. Who cares about this guy? Talk to him about flat Earth.
So we can have a full NPC reset again?
So, you don't know what a foil is?
Wait, what's
He's here to serve the
what's
purpose
what's an
of.
NPC
Yeah,
reset? Is that a crash out?
doesn't matter. It's a distraction from the topic. That's what it is.
All right,
Anybody
man.
want to talk more about him, or do you want to talk about flat Earth to the people that are listening?
All right, you wanted a good observation, Wake. All right, check the side
Yeah.
chat out. All right, this is 21 miles across the Great Salt Lake in Utah. All right, 1.5 meter observation height. All right, so if the Earth were a globe, there should be just under 300 foot of curvature over this distance. Now,
Is that coast that it's looking at? I'm seeing it looks like
it's-
lights. Is that a city?
it's like a little mining thing, right? I'll show you some top view pictures. So this is where it's at. It's just uploading. Just a second. All right, so this is, see the yellow line? That's the distance
Yeah.
markation tool. Okay, so he's standing up at that little peninsula at the top of that yellow line, and he's going to be zooming across to the shoreline on the other side. All right, so this is the shoreline on the other side that you can see in the zoom footage there. It's just uploading. All right, this is the shoreline. Okay, we can see the big white tower, and the shoreline's the target essentially. All right, so if we take the observer's height into account, which is in the next picture. All right, so we got the eye height, 5 foot, camera height basically. We got the target distance, 21 miles across the water. So the horizon, the geometric horizon should be at 2.7 miles. And the shoreline on the other side should be hidden by 223 foot. That's the hidden height.
Yeah.
Okay, now here's some screenshots from the zoom footage. Right, so he did it during the daytime. Okay, so have a look at the picture above the Earth curvature calculator. Okay, that's a close-up. And then this is the same tower, the same shoreline from 21 miles away during the daytime. And then he stayed there and he did it again during the nighttime as well. Because some globe earthers like to say, oh, you got these magical, perfectly lucky refractive conditions, right? So he stayed there, he did it again at nighttime. And it's even clearer at nighttime. So you can see the comparison of the three images there, right? The close-up, and then the shot at nighttime, the shot at daytime. And we can see the whole of the tower. Okay, we can see the shoreline. We can see the lights reflecting off the water. and we don't see any sign of that geometric horizon that should be there. We don't see any sign of any curvature. And then after they did this, they set up lasers, same height, 5 foot, and then they shot the laser across as well. And here's a picture of the laser. And then here's a picture of the laser signal being seen from the other side. It's just kind of like an icing on the cake. All right, so there's 3 different observations there within the same day, over 21 miles, showing that there's 0 curvature.
May I
And,
ask a question?
Yeah.
And I don't want to interrupt anybody, so it's just a quick question. What would people gain from not letting us know if the Earth is flat? What would they gain? What do you guys know
Yeah.
what's behind it?
Hold that question for a second, because I just
Okay,
did a
I'll
little
wait. I'll wait.
presentation.
I'm not trying to interrupt you.
Yeah,
So
that's
go
all
ahead.
right. Yeah, we'll just be a second, right? So, just if Wake wanted to reply to that that little presentation of the observation.
Nah, this seems like a good one.
It's a really good one, man. Yeah, it's there's a full video that goes along with it as well, which I'll just drop a link to it in the side chat if anyone wants to check out the full video. There we go. All right, so yeah,
So you
this
guys
is a
are of
really
the
good
position
one.
that like commercial space travel will never be a thing.
Yeah, like going to the vacuum of space and that kind of thing. Yeah, that's not going to be a thing. I mean, they've been promising commercial space travel since the freaking 70s. And yeah, it just doesn't ever happen. But this is the thing, right? If the Earth's a globe, right, you might be able to go up high, really high up into the sky or something like that. Okay, but when it comes to what's happening on the ground, right? Whatever you're going up above a flat surface into the air. Because when we go and check the surface, there's no curvature, right? If gravity was real, okay, you need gravity to have a globe, right? So gravity would have to be real if the Earth's a globe. Gravity meaning what most people think of as mass attracting mass, everything being pulled towards the center of the globe. Okay, that's what most of the globe earthers claim gravity is. Okay, so the water would have to be curving. Even if you go for Einstein's gravity, it still dictates that the water would have to be curving at a calculatable rate. Okay, so that would be 8 inches per mile squared over this distance. That formula would be accurate, and there would have to be that curvature there. It would have to be there. If it's not there, it would debunk gravity. It would debunk the globe. It would debunk anything that requires, right, that the Earth be a globe.
What if the globe is like 10 times larger than they say it is? Because I'm seeing, I think it was with the oil rig one too, that it's like you're seeing like 10 times farther than you should be seeing.
Well, their whole model is kind of based off that 3959 mile radius value being correct, right? Space travel, you know, everything, the distance to the sun, the distance to the moon, gravity, everything, right? So if that's wrong, then everything's wrong. And if it were bigger, right, it would have to be so much bigger that, according to them, all the continents would have to be in this tiny little section of this giant globe, including the North and the South Pole, right? So it just doesn't.
At this point, I could kind of see it.
Yeah, you could imagine it. You could imagine whatever you want at this point, but if you don't have any evidence for this giant globe that debunks the globe model, the current globe model, right, then it would just be a story or an imagination. And we're not even claiming to know the shape of the Earth. Okay, we're just saying that when we test for the curvature, it's not there. It's never there. And
what is sorry.
From a flat Earth perspective, what's the speculated like limit on how high you can go?
Well, it's not speculated, right? We have a height that we can send up a camera, right? So the highest we can go is like 40,000, 50,000 feet in a plane, and then the highest we can send up a camera is weather balloon height. Okay. Once you start getting
you got
above
any
that
weather
height,
balloon? You got any weather balloon perspectives?
yeah, I got plenty of weather balloon perspectives. But look, this is the thing. Okay, even according to the globe, right? Even according to, say, the globe scientists like Neil deGrasse Tyson, he says that you wouldn't even see curvature from that height, even if the Earth was a globe. So it's no surprise that when we send up a camera to that height, we just see a flat horizon. Okay, so even higher than that, he says you wouldn't be able to see the curvature of the Earth, even more than double that height. Okay, because the Jeff Bezos, sorry, not Jeff Bezos, Richard Branson had the Virgin Galactic that went up to apparently 300,000 feet, right? More than double the height of a weather balloon maximum height. And Neil deGrasse Tyson did multiple interviews saying, look, this is dishonest. They're not going to space. You wouldn't see curvature from that height. I did the calculations. So as high as we can get to, we just experience a flat Earth. Okay. There's also something called the Outer Space Treaty, which prevents people sending up their own satellites or their own rockets above a certain height, or sending a camera up above a certain height. It's not permitted, and that's why no one's ever done it. So yeah, there's restrictions, and there's also
interesting.
Yeah, there's also just these ground tests that we can do, right? So
yeah, you can see the curvature in space about like 50,000 feet up, I believe. You can start seeing curvature.
That's not space, right? That wouldn't be where space would be, right? That would just be the height of a plane, right? A bit above the height of a plane. And according to 50,000 feet, that's a bit higher than a plane.
Have you guys considered doing like a ride share with like SpaceX? Looks like you can send up like a kilo for like less than 5K.
No, I don't. We don't need to do that because we can check the surface of the Earth and we can't find any curvature over huge distances. Okay, so if someone did that, right? If someone wants to go up and validate that the Earth's curving that way, right? Then we're open to what's being done, right? And we'll check it out. But at this point, okay, we're not seeing any evidence that the Earth's a globe. Okay, because even if you're going to send a camera up to an alleged height, okay, what kind of lens is being used? There's a whole bunch of things that need to be considered. And people like to do that sometimes. They're like, what if this, what if that? It's actually called, appealing to the future, right? It's what if in the future someone does this or that? Okay, we'll address it when that gets done.
Mm-hmm.
Because they already said they went up to the moon, right?
Yeah.
Another guy had a.
Sorry.
Yeah, well, the other guy was waiting patiently to ask a question. What was your question? Is he still here? What's your name? Or maybe he split. All right.
I have a question.
Yeah, what's your question?
Can I go to the bathroom?
That's hilarious.
No, you cannot.
Bathroom.
Anyone got any better questions than that guy?
Oh man, you missed the perfect opportunity.
I think the angle that I would be on right now if I wanted to stay globe Earth, I would say this thing about buoyancy that you guys are using to explain like as an alternative to gravity, like
Oh, friend, it's not an alternative. It's not an alternative. It's what's actually observed.
yeah, I hear you. Like what about things falling in a vacuum?
Okay, so if something is more dense than its surrounding medium, it travels to the Earth. That's called falling. So if you put something in a vacuum, it's going to be more dense than the vacuum and it's going to travel to the Earth. It's exactly what we always observe. If something is more dense than the surrounding medium, it goes to the Earth.
Yeah, but do you not need gravity for buoyancy to work?
Well,
Like when
dude,
you
all his
talk when
gravity is, all his gravity
when you're talking
is,
about a vacuum.
yeah. Look, all you need is things to go towards the Earth. Why that happens, that's a different answer. Okay, what happens and why are two different things, right? You see what I'm saying here?
I see what you're saying.
So the implicit in the gravity claim on the globe Earth is a claim about everything's being pulled into the center of a giant ball. Well, let's just take that and throw it away, and let's just say everything's just pulled downwards, perpendicular to a horizontal plane. You'd end up with all the same effects locally that we can observe, right? It wouldn't change the observation at all. The only difference is that when you say everywhere I go, things fall down perpendicular to a horizontal plane, which is what we all observe, we observe that. The glober says everything falls inward to a giant ball. We never observe that. That's a story about what's happening, not actually what's happening.
Gravity's, gravity, as you guys claim gravity is, right? That's just kind of something that you need if you want to have a globe. Okay, you need to explain crazy shit, like all of the oceans sticking to the outside of a globe, and that kind of thing. Okay, so if you want to say buoyancy, you're gonna have to put gravity into your buoyancy formula on a globe. You're gonna have to have gravity if you want to have a globe. Okay, but gravity would dictate that water would be curving at X amount. And if it's not doing it, that would debunk your gravity. Now, we can all agree that things fall to the ground. Okay, most things are more dense than the medium of the air. It's a very light medium. It doesn't hold much. Okay, and if you just get a vacuum chamber now, all of a sudden, all you're doing is removing even more of the air. So it's an even less dense medium now. Okay, if you put something in a vacuum chamber, like a rock and a feather, they're just going to sit on the bottom of the vacuum chamber and they're never ever going to move. They're not going to just fall. Okay, they're only going to fall if you input some of your energy in one way or another and you displace them. You're going to have to lift them up. Okay, and then after you've lifted them up, energy has been exchanged. Okay, they now have kinetic energy, potential energy. And when you release them, they're going to find equilibrium. They're going to seek their natural place of rest due to specific gravity, or Archimedes' principle, relative density, whatever you want to call it, right? They're more dense than the air. You've lifted them up, you've displaced them, they're going to sink back down. The question at the end of the day is always going to be, why is there a down direction? And why is there an up direction in general? Okay, and that nobody knows the answer to that. Okay, it was like that when we all got here. It's something we can test. There's two primary directions, up and down. Now, if you wanted to claim that something's pulling things down towards the Earth, because that would have to be what's happening if you have a globe that's in a vacuum. Okay, so you would have to be able to prove the cause of the effect, not just show the effect and say, oh, this is gravity. And be like, well, what's gravity? And then when you ask questions like that to astrophysicists and people like that, they say, oh, we have no idea. We have no idea what gravity is or where gravity comes from. It just kind of has to be there for the globe to work, for the model to work. So on a flat, stationary, contained system, you don't really need that same thing. You don't need that mass attracting mass or that bending and warping of space-time to make up for all of the crazy shit that globers claim, right? Like oceans sticking to the outside of a ball. that kind of thing. We don't have to. We would say that if you want to have a body of water, you got to have a container. Right? You can't put water on the outside of a bowl without some magical force, right? If you want to claim something crazy like a magical force, then you're going to have to prove that. But we can easily explain why things rise or sink just due to relative density.
Yeah. So
Anything in
what's
nature.
the difference? What's the difference then in filling a cup with water and filling like a basin with water?
Well,
It's the
I
same
mean,
thing.
it's the same thing, yeah. But look, this is what we can do. Okay, we can test what we're saying. Like I can get an egg. We can set up a little experiment. Okay, I'm going to get an egg. I'm going to make a prediction that if I put the egg into the fresh water, cup of fresh water, that it's more dense than the water and it's going to sink. It's going to go down. And then if I change the density of the medium of the water, okay, by doing something like adding salt to the water, I can change what the egg does, right? The egg will now go upward instead of going downward. The only thing that was very manipulated was
the egg's
the
age
water.
is going to affect that too, because if the egg is
If it's a fresh egg, we're just talking
expired,
about a fresh egg. A fresh egg.
Yeah. Okay.
Yeah. So yeah, I mean, all we've done is we've shown that we can change the direction something goes just by varying and manipulating the medium, the density of the medium. I mean, it's kind of hard to debunk because anyone can test it anywhere, anytime, and it's going to work every single time. As far as I know.
It's crazy when you realize, wait a minute, this kind of makes sense. I remember that time.
Yeah.
I think it might be happening to him right now.
So somebody was saying something a few days ago about like this one dude put up a bunch of sticks and he was measuring shadow to prove that the world was a sphere, and like the Chinese did the same thing to prove that the world was flat, and they both came to the conclusion that they initially had when they started their experiment.
Right. Well, yeah. So both sides made presuppositions. Okay, so both tests are invalid because of the presuppositions. Eratosthenes assumed that the Earth's a globe, and he assumed that sun rays come in parallel. And then the Chinese assumed that the Earth is flat and that the sun rays come in, on an angle, okay, diverging away from the source of the light. And then they did their math based on their presuppositions and came to their conclusions. Both methods are flawed. Eratosthenes, there's not even any proof that guy even existed. Okay, he didn't write. There's nothing left at all that he wrote down, and then he wasn't spoken about until hundreds and hundreds of years after he allegedly died. And the Greeks loved making up these mystical figures as well. So like Pythagoras,
Could you not
Eratosthenes.
do the stick thing like modern day and in different locations and get different measurements?
You could do it. You could do it, right? But this is the thing, right? I could do it right now in the room that I'm in with the light on my ceiling. And it depends what presuppositions you make to what results you're going to get. All right? So if I did the exact same thing that Eratosthenes did, okay, I could turn on my light, put a stick underneath the light, directly under the light, and then there's not going to be a shadow. Right? And then I could put a stick on the other side of the room, and then there's going to be a shadow. Okay, then I could measure the length of that shadow, work out an angle, shadow angle.
Yeah.
Okay, and then now I got to make some presuppositions, right? I could think that I'm standing on a spherical surface, right? And that the rays coming in from the light on the roof are coming in straight, parallel. And then I could do the exact same math that Eratosthenes did and work out the circumference of my flat floor just by assuming it's a globe, right? And I can work out a circumference, which is obviously the outer perimeter of a sphere. Okay, obviously my floor is not a sphere, but I've been able to calculate the circumference of it just by pre-assuming that it's a sphere and doing my math based off that pre-assumption. Okay, or I could do what the Chinese did, and I could assume what's really happening, and this is what's really happening because I could confirm that my floor is actually flat by doing actual measurements across the surface of the floor. So I observe my floor is flat, I can measure my floor is flat, right? I also know for a fact that the light rays coming from the light on my ceiling are diverging away, right? They're coming out of the light bulb in all directions, right? It's diverging rays. So I can confirm that if I was doing what the Chinese assumed on the scale of my room, then my results would be correct. Okay, that my floor would be flat and that my light source is local. Okay, but on a grand scale, it's a little more difficult. That's why we would want to actually take measurements of the surface before we make assumptions.
Yeah. So if you set up like 8 sticks, like one in every cardinal direction along the equator of a globe projected, like a globe projection, and one in North Pole, one in South Pole, and then you got everybody together, right, over like some kind of call, and you had everybody measure the light affecting their stick. You would that not be of any value for like
Not really.
determining
No,
the shape?
no. All you're doing is measuring lengths of shadows. If you're not going to bake in any pre-assumptions, all you're doing is measuring lengths of shadows in relationship to the sun. These would just be angles.
Yeah, you're not going to be able to do it without making those same presuppositions.
So you're saying that like the distance to the sun is not a a known variable that you can use to like articulate this.
Correct. That's correct.
It's an apparent light in the sky, right? We
Yeah,
don't know the
okay.
size, we don't know the distance, we don't know what medium it's in as well, because they're assuming it's in a space vacuum and 93 million miles away and all of these things, all of these assumptions. Okay, I would say that the sun is an apparent light in the sky. And look, here's the thing. If you're looking at the sun, let's say I can see the sun and you can see the sun at the same time, but we're huge distances apart. If I draw a line from where I can see the sun, right, a line from my eyes, imaginary line straight to where I can see the sun, and then you do the same thing. Okay, those two lines are not going to intersect at the same point. Okay, because you're seeing the sun unique to your position, right? Unique to your perspective, unique to the atmospheric conditions of where you're at as well. Okay, so it's not going to, it's an apparent light in the sky. Okay, 20 people could do that, and none of their lines are going to intersect at the same point in the sky.
Now,
The
like
sun's
DJ
crazy. It
mentioned,
does also.
you could skip all this stuff. Oh, sorry, go ahead.
No, I'm done. Go ahead, Cece.
So, like DJ said, the better thing to do than measuring shadows with all these baked in assumptions is to just go ahead and measure the surface in which you're trying to measure, right? Like with some kind of straight edge. So, if he's in his kitchen or in his room, right, he can take a straight edge and he could lay it against the surface of the table or of the floor and find out how much deviation there is from the straight edge, something that you know that is true and flat, and have a measurement, essentially of how flat it is. Now, it may not be perfectly, horizontal like the straight edge is. You would have to get the deviation from the straight edge. However, if it's a ball, you have a very consistent relationship between the deviation or the drop over the distance according to the straight edge, right? So that would be the best way to figure out what it is that you're on instead of measuring lengths of shadows with pre-assumptions.
I see what you're saying.
Oh, I could do the same thing in my room right now with 20 different sticks. right? Still the same problem at the end of the day. Two sticks, 20 sticks. At the end of the day, my floor is still measuring flat. Okay, but if I presume it's a ball and then do the same thing with 50 sticks, it's still going to be a flat floor at the end of the day. That's why measurement always trumps assumption, or a calculation based on an assumption. A direct measurement's always going to be what you should do first, and then you should base your calculations off the measurement.
I think I understand the angle that you guys are approaching this from. You're approaching this from, like, if it's a test that you are not capable of doing yourself, then you question, like, the validity of it. So if you need like 100 scientists doing 100 different things in some specialized piece of equipment that cost $100 million to build and needs like this huge footprint of land, because that's not something that you are capable of replicating, that's not something that you're capable of accepting into your doctrine.
Well, not
Could you give us an
necessarily.
example of that? Because could you give us an example of,
Well, I
if you
I
want
don't
to
mean
appeal
it.
to scientists
Yeah.
doing this?
Well, let me
Who's doing
clarify,
this?
right? Let me clarify. I don't mean that in a derogatory way. What I'm talking about is, like, if you've got like these guys at CERN and they've got like this who knows how many $1 million fucking like giant donut, you're not able to replicate their results, so presumably they could tell you whatever they want.
Well, that's fair, but that we're not talking about whatever they're doing at CERN. We're talking about surface measurements of the Earth, which we have all the access to the things that we need to do that. Like there's really no need. I don't know what the cost of the equipment would be, other than if you wanted to create a very large straight edge, right? And if it's going to be made of material, then that material is going to have to hold some kind of rigidity as you teeter it, out beyond whatever length you're going to need to teeter it. But we don't really have those materials. So the next best thing is a laser, right? Or since we already know that water finds its own level, which is horizontal, flat, level across the surface, since we already know that, we can use water. So there is no equipment, there is nothing to do to measure other than to use what we already have, which is the Earth, some kind of material that shows, horizontality or straightness, like a laser beam or water. We've done all that.
Yeah. Well, what shape is that big fucking ring that they got in CERN? Like, is it a perfect circle that is completely flat, or is it like a circle with a slight curve to it?
Well,
Sure, man.
okay, so it's not a perfect circle if you look at the, basically the breakdown or the diagram of it. It's under the ground, right? So you can't look at it, but it's not a perfect circle, I don't think. And then if you're going to ask, is it curving? Well, it still wouldn't matter because it's underneath the surface of the Earth. So if it has, some variation in the, we'll call it the y-axis, doesn't matter.
It's got eight arcs and 8 straight sections, so it's not even a circle. It's a hexagon, octagon.
Yeah, I don't think anyone claims that proves the globe or anything like that anyway. Okay, but yeah, you are right that if someone gives you some information that you can't verify, then that's going to be faith-based. But it's worth analyzing it and looking at it, looking at the logic behind it, and checking it out. But if I mean, we could probably debunk some of these things just by testing the surface of the water. Okay, but if you can give us an analogous example of what you're talking about, we could go over it. Okay, who says they have some
I was just saying
amazing
with
equipment
the
that they use to prove the Earth's a globe?
Yeah, well, I mean that's kind of what I'm saying is like let's say there. I know you guys don't really like hypotheticals, but like if there was some like experiment that you could do that would 100% prove if the Earth was a globe or not, but you need $1 billion piece of machinery to in order to measure it, and then you need like 100 different guys with 100 different specializations in already specialized fields to analyze it, and then that group of people would come together and piece it all together and then tell you what they think it is.
Yeah, well, I know you don't need that. I mean, that's the problem there. Okay, that's not something that exists, and it's not something that you would need, because it's very simple, right? If the Earth's a globe, the water would have to be curving at a certain rate. There's no evidence of that. Okay, I don't see why you would need some $1 billion machine to be able to just test the surface of water.
It also
I
is
mean,
interesting, if we were to play around with your hypothetical, why hasn't that been done?
Well, I'm sure they would say, well, it's already been done. We've got rocket ships that can shoot you out far enough, and then you can look down, and then you can see
Whoa,
that it's a globe.
whoa, whoa! You sorry, you were talking about specialized equipment measuring surface curvature, and then I said, well, why hasn't that been done? And you went to rocket ships, and then video, and trust us, bro, not the same thing.
Well, I'm saying that's what I think they would point to. They would say, well, of
Well, if
course we can prove to you it's a globe, but we would need to bring you up into space to show you it's a globe. But then you would need to trust that the thing that you're looking through isn't a screen as well.
Well, that's the thing. So, are you saying that the claim of the globe or the curvature from seeing curvature from outer space is unfalsifiable? I think I have a problem with that.
Okay, what do you mean?
I mean that it is something that I cannot falsify. It is a claim that can't be tested.
Yeah, yeah. I mean, it depends on um, like what your degree of, or I guess what your nature of belief is for the reason why you've like come to the point where you would conclude that the Earth is flat. Because like I can see like the reasonable end of that being like I I just have like it's like an integrity thing. Like I need to be able to know the result for myself and not have to take somebody else's word. And then there's like the extreme end where it's like, yeah, even if they shot me up in that rocket and maybe look through a window, it could be a screen. And then they're like, okay, fine, here, put this helmet on and go outside. You can do a spacewalk. And then they're like, well, that could be like a screen too.
Nobody here
Like
is claiming that. The problem
you would
is that
need
it's not a falsifiable claim. However, as far as seeing curvature from way high up, all right, at whatever height that they're claiming. So as far as I can tell, we actually need to get to about where they were at the moon or halfway between here and the moon, in a heliocentric idea
yeah,
to see that. You and I don't have that ability. We just don't.
yeah. No,
Now,
I
you
agree.
could, right? So if we just don't have that ability to falsify that claim, the next best thing, although I think it is actually the first best option, is to measure the surface on the surface with the equipment that we have and the technology that we have. And that's what we do. And so we say, well, if I can't falsify a claim that's supposed to be halfway between here and the moon, what I can do is falsify it on Earth and say, well, if you're going to show me this picture and I can't go, I'll just check while I'm down here. And to me, that's the best option
Yeah,
because I have direct access of the thing that they're claiming is curved, and it isn't. What also is fishy is that the more that we have dug into, all of the writings and the postulations of all these scientific priests out there, is that
yeah,
they're actually admitting to us that it is flat and stationary anyway. They're actually saying, well, we treat it like it's flat and stationary too, but trust us, bro, it's a ball. So everything
Yeah.
that they're doing is measuring flat and stationary. So
Yeah.
they're saying trust the picture, ignore what we tell you directly, and believe in what we told you when you were in kindergarten and all the way
Yeah.
through whatever, you know.
Right. Okay. I have a question. Do you believe that there is a roof at any point?
Me personally, yeah, I think this place is contained.
Okay, so even if you do like, and I know you guys don't like hypotheticals, but like I'm trying to I'm not using it to try to like make you say, oh wow, the world really is a globe. Like I don't have any delusions about converting anybody. I'm not even trying, right? Like I'm curious about this because like I've seen some things and heard some things that made me think, oh wow, that's really compelling, and I've heard other things that are less so. But what I would say is if you accept that, like, let's say we have a super advanced rocket, super crazy, it's like a nuclear rocket that can like go super fast and it can burn forever. Uh, if the world is flat and you have this super advanced rocket and you begin to go up and up and up, at some point you're going to reveal everything that we already accept to be there, right? But if you keep on going up past that point, like what are you seeing on the edge? Like is there an edge as well, or does it just go on forever for as long as you can go up and observe out?
Well, I mean, this is all asking me to speculate on something I would not be able to prove, right? So what we can demonstrate is that as far as we can tell, we have a volume here under pressure. The height of what the container for this pressure might be at, I have no idea. The limit to the realm, where there might be this edge, no idea even where to find it. So I don't
Okay,
know which
well,
direction to go to find this edge. But if we have water and gas under containment, it is
yeah.
safe to assume, right? I can say assume that this place is a contained system.
Should that not be something that you attained under that pressure, you would be able to calculate the size of the like vessel containing that particular
No,
pressure with that particular gas makeup. You would be able to approximate it.
no, you can't. And I'll tell you why. Because I can get you 1 cubic foot container, right? 1 foot by 1 foot by 1 foot, and I can fill it with 17 or 14.7 psi. I can also take a 500 cubic foot container and fill it with 14.7 psi. And all I
Oh,
know
okay.
is the
I see
gas
what you're
pressure.
saying. I see what
Yeah,
you're saying. You would need also to have some way to measure the forces being exerted on the structure, on the vessel itself.
I would need
Like the way you
to know a
measure like
size. I
tire
have to know
pressure.
a size. Yeah, but there's all different sizes of tires, but they can all be filled at the same pressure. So it's not going to give you a good gauge of surface area or total area. It's just not, or volume. It's just not going to be able to tell you that. Pressure is pressure. That's what we measure.
Wait,
Length, width,
but we
height.
can.
Those are things we measure. Hello?
Yeah, no, I'm just I'm thinking on this one. We know what the pressure is, and we know
Mm,
the base size of the flat base.
I
No,
don't think we do. Nope.
You don't think we have an approximation on that?
Nope.
no.
So you think there's do you think there's hidden continents?
Well, that's a
We don't
different
need to make
question.
claims.
So let's pretend for a moment that the size stays the same, but there's land within the size that we think we know that we're not aware of, right? That like there could be quote unquote hidden land within the area that we already know that we live upon. That's kind of a given. You can look at maps that are 300, 500 years old, and there are pieces of
Yeah.
land, right, that apparently people have set foot on that are on those maps that are not on the maps that we have today. Does that mean that all of a sudden those places are underwater? With each other, actually. You know, what the quote unquote shape of the realm might be to get a good gauge of what the surface area actually might be. And we don't have that
Yeah.
ability,
Do
as
you
far as I
think
know.
what is your angle?
Conspicuous region, you know, kind of like low Earth orbit, we'll call it, you know, out there beyond where the air really is thick. And this technology is hurling around a sphere tethered by a force, non-force called gravity. Is that the assumption that you're making when you say satellite?
I think so. I mean, what I'm saying is,
Okay.
do you think that we do have like man-made objects in the air above us right now?
Well, in the area, yes. I mean, earlier I posted one. You know, we have satelloons, got tons of those. It turns out Google and NASA have huge balloon programs, probably along with a lot of other major corporations that do this for whatever purposes. Those are very common. Um, and they're very reliable. They're actually much more serviceable and a lot cheaper than trying to shoot something out into a vacuum and have it orbit a ball that doesn't exist.
Oh, interesting. Well, this is they're inflated with gas after reaching orbit, so they do still launch them. It sounds like.
No, most of them are launched from the ground, but you
Yep.
can launch them from altitude as well.
And they will
We have footage of them
capture
being
them
launched.
during, yeah. They also capture them when they begin to descend, when the amount of helium that is in the balloon begins to finally wane, like it leaks out eventually. But they can be up there for, I think, months at a time, not many months, a couple of months at a time. But after a while, the helium does leak out. You know, that density relationship starts to change and they begin to descend. So they will send out planes with these big long hooks on them and they will just capture those balloons and quote unquote satellites, the pieces of technology, take them down, put them on another balloon, and send them right back up.
Okay. So, but you would trust like the results of a GPS then if you were able to like get it into a region that is not currently acknowledged,
Well, that's
widely
a
known.
weird question. I would. That's a weird. Is that a question? What? So I would believe that someone could be in a place that we don't know about.
No, I'm saying like would you be able to trust those results?
What results? I mean,
Of
like
like
what kind of?
like a GPS ping from somewhere like off the map.
This is a strange hypothetical. I mean, you're asking me about something that, as far as I know, is not occurring. And then if you say off the map, well, that means somebody has reached another region that isn't actually on the map that we have. I would say, well, ain't this some bullshit? We've got somebody in a region that is not on the map, and the amount of time it took for us to get a ping from them certainly does not fit the available or known, you know, area of the Earth. And I would say, well, there's more area that we were not aware of. That's all I could say.
I mean, I think that'd be kind of cool if it's like a bunch of flat Earths and they're all like divided by a billion ocean, and that's how you like encounter aliens. So like if you got the right route, you'd fight them on the water like alien pirates.
Bro, you're okay. You've decided to go into, like, I don't know, sci-fi land in your imagination. Okay.
Yeah. I just it would be cool.
So, Wake, what do you think? What do you think the likelihood is that when we were all told about space, right? And I know that space has been fairly well described and defined as a region very far away from the Earth, right? Uh, um, that essentially is an extremely low pressure region, right?
Yeah.
Um, and there's not a lot of life. There's some, stardust and all this other crap, and a handful of gas giants and blah blah blah. Um, and then you've been given like some imagery, especially in the sci-fi where Star Wars and Star Trek and Marvel movies, and there was a movie back in the '90s called Event Horizon. You ever heard of it?
Yeah.
An
Yeah,
alien and all
is
that
that the one
stuff.
with the bomb necklaces?
Oh, I don't remember bomb necklaces. I remember uh, essentially it was about a handful of people on this ship that were overcome with this evil, right? Because they were traveling through a region that they'd never traveled through before. Anyways, I digress. Anyways, just
Okay.
all the imagery that you've seen about what space is, right? But do you think it's possible that perhaps when the more official talking heads, quote unquote scientists, cosmologists, whatever,
Yeah.
astrophysicists, and even in colloquial uh, discussion, when they talk about space, they're actually only talking about the region above the surface. That is ultimately space. And we've been all just thinking of it incorrectly. Perhaps that idea about, the galaxies and the black holes and all that stuff uh, is just kind of fluff. And ultimately, when they say space, they're just talking about the open space above your head.
Okay, what are you asking me?
Well, you could say a word, and someone could assume that you mean something. Well, it's kind of like words that have double meanings almost, but there's
Okay.
a very common meaning to it that everybody sort of appreciates. Because if I say the word space, ultimately you think about the vacuous region with all the stardust and the galaxies and the asteroids and stuff, right? Isn't that about
Yeah.
right?
Yeah.
What if somebody else, when they're saying space, only means the space above your head? And
I get what you're
you,
saying.
with with the poor assumption that you know what they're talking about, are talking about something completely different.
Yeah, I see what you're saying. So I think when I think of space, my default is to think of it as like as if we were on a globe and that we can enter into some kind of medium to transport between other uh like spherical objects orbiting in, sort of like circular kind of shapes. That is my go-to, but
Um,
I'm not totally against it just being like if you just keep going up, it just keeps on getting thinner until there's nothing there, and that it's flat as far as the eye can see because like there still presumably has to be an edge at some point somewhere. So like fucking whatever like explorational equipment we need to get to that point, fucking drill baby drill, go find what's on the outside of whatever we're in.
well, yeah, I guess I would agree. It would be nice to know if there is a limit to this place, where it is, and how we could find it. Right? No worries. But What I'm talking about is earlier it was mentioned that one day we were going to have commercial space travel, and I would like to posit the idea that we already do have commercial space travel.
If we're talking about airplanes,
Yeah.
yeah, I see what you're saying.
So you could say that something is going to occur, and you know what you mean, but everybody else thinks you mean something different. Now, I'm not saying that's what's going on, but if somebody came in and said, well, one day we're going to have commercial space travel, I would say I think we already do. And they would say,
Yeah,
"What do
well,
you mean? Are you talking about Bezos? Are you talking about, Richard Branson?" And I would say, "No. The space above our heads is being traveled commercially daily, a lot."
yeah. Well, I mean, even if I did like accept flat, right? I would still want to know like where the fuck is the edge and how do we get there? Because like, if circumnavigating the globe is happening because you're walking in one big circle, then I want to walk in a straight line. And I want to keep going in a straight line. And what do I encounter if I reach the end of that straight line?
I mean, that's a fair desire. I would also like to see what happens if we could figure out the reference system to travel straight like a crow would until we hit something. That would be cool.
Would you not be able to? Yeah, that's something that you should be able to calculate, right? If you take like a route that is a circumnavigating route that could, like, you could just say around the equator, right? Just to reference like this point and then this point and this point and this point broken down however far you need to break it down, so you know you're traveling along what would be a complete circuit of a globe Earth, and then you apply that with it, like, so you would be able to like say like I don't know the math because I'm not a math guy, but you should be able to say if this route is overlaid on a flat surface and it is presumed to be a circle, then you should be able to unwind that to figure out what the route would need to be a straight line, and you should be able to use that to give yourself a vector to follow.
Yeah, but how
Right.
accurate do you think you have to be?
Honestly, I don't think you have to be too accurate because even when you're traveling over short distances, if you make like a small mistake with like, oh, I did like 93 degrees instead of 93 and a half degrees, once you travel over a far enough distance, you're going to be way off mark. And the point about what you would be doing here is like you're aiming to go off mark. Like you're
Yeah.
aiming
So how
for
how do you know
what's not already
you're off
explored.
the mark, right? How do you know it's you that's off the mark and not the map that's off the mark?
Yeah, I don't know. I don't know. Like you would have to accept
Correct.
the map for what it is, but I mean, there. What I'm saying is,
We have
where's
some
the
big
edge?
issues with maps, okay? I mean, extremely big issues with maps. We could get into it really deep, but for the sake of the conversation and the audience listening, it's probably best we don't right now. There's something called a transport rate, which is the deviation that you would have as you go around in a circle versus a straight vector. And I'm here
Yeah.
to tell you that the transport rate is not measured by any airplane, not even by satellites. It's actually calculated. It's calculated in order so that these navigation systems could put the airplane or put the satellite somewhere relative to a globe. That's all these things need to do. That's what their job is to do, is to put the asset somewhere on this coordinate reference system, no matter where it might actually be.
Okay.
Yeah, the fact that we can prove that a transport rate is a calculation and not a measurement should make you scratch your head and say, why is that, right? So we measure the Earth flat with lasers, and you know what? It starts to make sense. Didn't mean to
then,
hijack
I
the
mean, that makes
conversation,
it
though.
well
Carry on.
that makes it even easier, right? Because shouldn't you be able to navigate towards like the edge by following like a path of lasers?
I don't think that there's an edge like you can fall off a flat Earth.
No, I'm not saying you fall off. I'm saying like it keeps going.
Yeah, like to where I don't know where it terminates, man. I don't know how or if anybody's actually done that.
Well, why would it need to it doesn't need to terminate.
Well, funny thing is we're breathing gas pressure, which means there is a limit to the volume, which implies very heavily, if not proves, that there is some kind of containment that we're in.
It could just be a flat plane above us.
Yeah, but if the plane is infinite, and if our container is infinite, then the volume would be infinite. And this presents some really interesting problems regarding entropy and gas behavior.
Okay,
We live
so it needs
more or
it.
less in a
So
realm,
hold on.
dude. This is the realm.
So
We don't live in
so
an outer space Big Bang cosmology.
so are you saying that this stuff with entropy and whatever else, do you need to have like a set amount of like volume of gas, and then it's okay, and if it's infinite it's a problem, or it's okay when it's infinite and it's not okay when it's a set amount?
The fact that we have pressurization means that there's a limit. You're breathing gas molecules that bounced off of something somewhere.
Okay, but so what's the reason again that you're not able to calculate the size of the container if you know
Oh,
what the boundary
calculate it?
pressure is?
Yeah, I
Like
don't think we have
approximate.
enough information to do that.
What other information do you need? Like we have like I guess you're saying you can't necessarily trust
Yeah,
the
you might
size
need to
of
know
the.
like the total number of moles or something in the system. It's like no, we don't have way to get to that.
Yeah, if we can only measure the pressure up to a certain height, which isn't very high. It's like what 40 kilometers up or something like that. That's the maximum height a barometer will work.
Now it's possible this place is really freaking huge. Like I would say that it's possible that there's more landmass to our flat Earth reality than there might be landmass that wraps around a fake globe.
So
You know, but there has
are
to
you
be a
guys
limit
chill
to what
with
we breathe.
are you guys chill with ice walls?
I don't think ice walls contain our system. The whole ice wall thing comes from flat earthers who look at a globe map that's been flattened out.
Yeah, that was actually a term given to, the coastline of Antarctica by the United States military, and the flat earthers picked it up because they were looking at AE maps. But I mean, is there an ice wall?
Yeah.
Apparently so. Is it surrounding the azimuthal equidistant Earth? I don't think so. There's no way for me to prove that.
Yeah, I think Antarctica is an island continent, but there may be multiple ones for all I know.
But what if the North Pole and the South Pole are not uh they're walls, but not like circular walls, like just like straight walls, east west?
You mean like a rectangular map?
Yeah.
That'd be pretty wild. The issue is though
That would force.
the Mercator map that you're invoking right now is still based off a globe. The latitude and longitude are still spherical coordinates.
So what do you get then if you just like collect every map every culture had in like, you know, the end of the 1600s, and then just like fed it through an AI or something like that to average it out to determine what the surface should look like.
Well, garbage in, garbage out, because the problem is for hundreds and hundreds of years, even longer than that, going back to Ptolemy, they've used spherical coordinate references. So they've used a spherical topology for almost the entire time. You know what we
Spherical?
truly need is we need to survey the world divorced from the celestial sphere model. The celestial
Well,
sphere, by that I mean
that-
how the heavens are imagined to project themselves to our eyes.
Yeah, well, I mean that seems like something that you could do. That seems like something that you could do like a big project about. And you could,
Well,
Might
it's one
cost
thing
billions
to
of
do it.
bucks when you're talking about the oceans.
Yeah.
yeah.
So
I
on the
guess when you
land,
get to
that's
the
exactly
ocean.
what they're doing. Over the land, they are surveying it as a vast plain, believe it or not. But when you get over the oceans, all bets are off.
Like how do you use the stars to navigate by Antarctica when it's going to be winter in Antarctica at the time you can see the stars mostly? I mean, you're probably not going to survive. So in order to survey Antarctica or places around it, even using the stars, you're going to have to maybe select 3 months out of the year.
Well, if you hold on, all right, if you do like a proper like a proper survey of, say just like North America and South America, right? And then you project that onto a flat surface like a grid, right? You'd be able to line it up. And then
No,
you could do the same. No?
no, because if you begin with the spherical coordinates, you're already projecting the sphere flat, which is distorted. Because the distortion comes from the sphere that it's projected into the coordinates in the first instance before it's then projected flat.
I see, sure. Well, what if you
Yeah,
just went with like here we're gonna make a point right here in the middle of America, or what we presume to be the middle. It's not gonna matter. You make a big rock there, right? And that's your anchor rock. That's what we're gonna draw. That's like our
sure.
first node on the map. We're gonna draw from here. We're gonna look to exactly where
Yeah,
the sun comes.
that's how they do it flat.
Yeah, so you go to
No,
exactly where the
tell
sun
where the
comes up
sun comes
on
up.
January 1st, and you go exactly where the
Nope, don't
sun
want to
goes
use the
down.
sun or stars. Nope, 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 nope.
You
Don't
can't
want to
you
use the
can't use the
stars.
sun?
Nope. No, because the way that that's portrayed and imagined is to be operating within a spherical framework, but
Okay,
it
interesting.
really doesn't manifest that way in reality. What you
Okay, sure.
need,
Then you just point
what
two random
what you need
directions
to do
and
is
be
to
like, this is
use the land itself.
yeah, sure. So just point in two random directions, be like, this is now east, this is now west, and then you square it and be like, this is now north, this is now south, and then you start measuring out from that point. You measure out your first kilometer, or your first whatever, however many kilometers,
Yeah,
and then you square it up,
this
and then you just
this
build the
is
grid
done.
off that.
This is done. We have examples of that not only in the U.S. but most famously, the British government. The British national government has something called the British National Grid System for the UK Ordnance Survey. They surveyed a swath of the Earth, 2,500 by 2,500 kilometers square, without regard to latitude and longitude, without curving it. And if you were to take this massive square grid and slap it on a globe, it doesn't match the coordinates on the globe at all.
Are
So
you are
there's a
you
great
okay with
example of a massive map.
are you chill with like deep sea maps, or do you presume that to be unreliable?
It depends. It depends. So with bathymetry, they use depression angles with LiDAR or radar in order to scan the surface. The problem is where the boat says it is hooked up to GPS and is using spherical coordinates. So all that data, if it's going to be calibrated to WGS84, some spherical reference system like that, it's going to be mathematically bent as they measure it.
Would you not be able to just like unbend it and figure out what the projection would be? Because you know how they're bending it to give you the distortion.
Possibly. I mean, I think the military does this, and nobody has access or has much knowledge of it at all. That's just my personal opinion.
So yeah, you could do this. Now, here's the funny thing about the reference coordinate system that they use, right, which is the sky, essentially. They're also sort of treating those stars and everything that they reference their measurements to be basically fixed. And in reality, as far as we can tell, the stars are not in a fixed, I want to word this very carefully. They're not in a fixed location, meaning in free space, you can't run up and touch them. So they're apparent. So it's almost like an apparent system, right? An apparent reference system that everything is attached to. And we still ultimately don't have a solid way to measure points on the surface with a good solid reference system. Like what you're talking about, if you had an anchor or a point on the surface of the earth that you were going to always reference to your distance from and your angular relationship to it so that you could get a good map, that would be great. The problem is, let's say you would probably need some kind of beacon or repeater or whatever, radio, I don't know. But after a while, distances cause problems, like the same way that they do out in the ocean. So when the distances cause problems, and then maybe even the conditions cause problems, the further you get away from that beacon, the less your measurements are going to be very reliable. So we really actually don't have much to anchor to as a reference point to get a full understanding or map of this place. It's very difficult.
That's a good point about the stars. It's worth repeating. Flat or globe, you can't triangulate the position of stars in the sky, period. And for this reason, there are some very novel ways to map the Earth that provide coordinates to you, no matter what shape the Earth actually is. One of the ones I came across is called Gaia, like Gaia, Gaia. And the Gaia system treats all the stars that you see in the sky as vectors, not as points that are fixed. Like Sasu was saying, fixed. They're not fixed. They are vectors. And they're observer dependent, which means if you have multiple observers all pointing to the star, their points don't converge to the same place. They converge in different locations. And it seems irrational, but it's not. It's consistent. And the closest thing that I can come up to analogize this is a rainbow. A rainbow is an optical effect. If you point at a rainbow and I point at a rainbow and says who points at the rainbow that we all see in the sky, our points will not converge at the same location at all. You can't go to where a rainbow even is. And it seems very much that the sun, moon, stars, and planets manifest themselves in a similar way as an optical effect does. So, the Gaia star tracker functions under this premise, and it doesn't matter what shape the Earth is. The Gaia star tracker is used on some satellites and drones today. Isn't that fascinating? Funny enough, Stellarium, your favorite planetarium software, also works on any shape of the Earth, flat or globe, or dinosaur nugget or banana or whatever these clowns come and say day after day.
Interesting.
Yep, that's right. the key is observer dependence, which it truly manifests itself to be, just like rainbows. So, you can create an internally consistent coordinate reference system out of the sky, and you interpret the sky as a sphere. As long as you use it consistently, you're going to get consistent results. And you might be so convinced as to think that that's what reality's like, when it's not. I mean, it's kind of like the idea of using GPS. You ever have GPS take you the wrong way to a friend's house? Well, I mean, it'll still get you there, but it may not be the most optimal route. I firmly believe, based off of my understanding of topology and how we've mapped the world using stars, treating them as a big sky dome or sky sphere, that the globe misrepresents the true distances and orientations and even scales of things,
Yeah,
all the continents.
covered.
It's really funny when you think about it too. Like I'm old enough to remember the first Iraq War, when the Scud missiles that Saddam Hussein was launching all over the place into Kuwait and other areas were way off course. They're way off course, and the Western world was mocking him for using a shitty guidance system. I mean, wouldn't it be funny if he was using the globe one and everybody else uses a flat Earth guidance system?
No, but he did that on purpose sometimes.
Yeah, just to terrorize
So-
people. Yeah.
Sorry, newcomer, did you have a question or were you commenting on the current conversation? Okay, moving on. Man, they just keep getting dropped in here when they're finishing their
Yeah.
conversation that they got booted from.
In celestial navigation, there's this so-called rule of thumb, the 69 to 1 rule, that for every 69 statute miles you go in one direction, that the star field, the celestial sphere, rotates about you by 1 degree. To my knowledge, well, first, this would require, if it were true and consistent everywhere on Earth, it would require that Earth has the same topology as the sky from which it's mapped from. So if you're treating the sky as a globe, then the Earth is going to be a globe if you apply this rule. The issue is this rule's never been independently verified, to my knowledge. And the kind of instrumentation that'd be required, I think, is probably very expensive and the methodology very complicated. And what's funny is we do have records of surveyors going back to the 1700s, even the 1730s, like the French and the English. They noted that the 69 to 1 rule was not consistent. They sent out teams of surveyors all over the world to go figure out how inconsistent it really was.
What do you think about gravitational anomalies?
Yeah, it's weird. I mean, I'm open to the idea, insofar as there are documented places on Earth where pendulums swing faster than they should in other places. I don't know how much to accept regarding those claims. But I mean, even the mainstream literature says that the gravitational acceleration of 9.8 meters per second squared is an agreed upon average, and it's not always consistent everywhere on Earth. It's not even consistent amongst elements. We've got a famous study, the Bremen drop tower in Germany. I think it was like a 300-foot vacuum tower that people do drop experiments in. We've got a video, we've got some papers on a guy or a team rather, that set up a tray of different elements, different atomic elements like barium, magnesium, iron, copper, and lead, and others, these blocks. And a camera was attached to a tray at the top of the vacuum drop tower. And it was watching all the elements, and the camera and the tray would all drop, boom, and the elements lifted off the tray at different times, thus implying that whatever gravity is was affecting them differently. It wasn't much, but it was enough. If you talk to geodetic surveyors, they'll tell you that plumb lines aren't straight, that if you drop a plumb line in certain places, that the plumb line doesn't form a horizontal corresponding to the vertical. In fact, they even say it gets worse, that if you could hang a plumb line down a mine shaft, that not only would the plumb be deflected or shifted off in one direction at the bottom, but the line itself would curve.
Is there any are there any patterns with that?
Nothing consistent, but they've mapped this so all over the earth. It actually ended up in something called a geoid model. And what they did is they took their mappings of this phenomenon and they wrapped it around WGS84, giving every location spherical coordinates and the associated distances and orientations with respect to each other on that map. But if you were to unwind it from that map, if you were to use a planar survey and put those locations down instead, you'll probably have a different result altogether. I mean, you'll have the same lumpiness, but you'll have it in different areas because the world would be surveyed different.
Yeah. Yeah.
Yeah, pretty trippy, right?
It is, yeah. I'll be back in a little bit.
Okay, cool. What's up, guys? I know I kind of barged into that conversation, and I'm sorry for taking it away. We got some people talking to us, and we might be the first genuine conversation, in-depth conversation they've ever had with a flat earther. Give them food for thought. And they go out into the world, right? They start Googling flat earth. Or they come upon like flat earth on Twitter. And they get something else completely different altogether than what they get here. So I just hope what we say keeps them coming back for more, because I think what we have to say about the matter is different than most other places you'll get this from. See, I've got some notes on the topic that we were just discussing. going to go through them, see if there's anything worth passing on here. If I can scan and chat at the same time. Let's see. Timeline. Just trying to put together a timeline of geodesy. The timeline of geodesy, that's so-called measuring the globe, right? Focusing on logical gaps and fallacies. So my research, I came across, maybe it might be worth to go backwards. So we have the gold standard, not really the gold standard, but the common standard is WGS 84. World Geodetic System, I think it stands for, that's what the S is, from 1984. And this is actually a pretty complicated latitude and longitude grid with dimension of the Earth. It's claimed to have been an evolution of earlier models enriched with satellite data. And what's funny is they make big deals out of little variations and differences over prior models without the satellite data. Like, wow, what an expensive capital outlay to get virtually, nowhere. Kind of like how they make a big deal out of the equator being a bit chubbier in the middle, and they're like, yeah, Earth is oblate. And you're like, well, how oblate? 14 miles over a 4,000 mile radius. They make a big deal out of that oblateness. But WGS 84 is fundamentally built on the chassis of the Clark 1866 ellipsoid, Ross Clark, explorer, surveyor. So what he added to his datum that he was working off of was more measurements of the sky with respect to the ground, the rotation of the stars, apparently as you move around. But this ellipsoid itself was based off of an earlier ellipsoid called the Bessel ellipsoid. And even preceding that, something called the Airy ellipsoid. These are all mathematical models coming around in the mid 1800s, early to mid. But these ellipsoids were never really standardized or put together until then, because prior to that, people were just measuring arcs. And there was no standard way to glue together all the arcs that they were measuring out of angles in the sky into a cohesive ball. But people still had an idea of Earth as being a globe. Back in the 1700s, let's see, where should I go with this? There's an event, the French geodesic missions to Lapland and Peru. So back during the early to mid 1700s, the French and the English were at a big disagreement with each other over whether or not Earth was shaped like an egg, that is to say prolate, or kind of flattened like a flattened soccer ball, so oblate. And that was like the great debate. You had like the King of England, the King of France arguing over tea, whether the Earth was longer at the poles or fatter around the equator. So they all sent out their teams to go figure out and try to settle the affair once and for all. What I find fascinating about this story is the time place it took in, early to mid 1700s, 1730s. You mean to tell me with 1730s knowledge of the world and technology that you could take a team of surveyors and send them over to Peru, to the freaking mountains, the Andes Mountains, to go survive in the wild? I mean, like, just think about that for a minute. French people traipsing around the New World in the Andes Mountains to just go measure the stars and somehow figure out how much land you've traversed through the jungles and the mountains and the valleys to see if the sky rotates at an even 69 degrees per, or 69 miles per degree. And then they sent another team to Lapland, which is like northern Finland. Do they have polar bears up there? To go do the same. The idea was to send one team over by the equator and one team over near the North Pole, and we'll see if the Earth is egg-shaped or squashy-shaped. And the squashy shape won out. And this is where we get the idea that Earth's an oblate spheroid from these people that supposedly did this. I really don't buy their accuracy, their methods, or anything for a second. Like, how many sandwiches did they have to eat on this trip? You know? How are they getting food and water? How are they living? How are they writing down things in their journals? Did any of their equipment break? Did anybody die? Did anyone get injured? Anybody get a toothache or a broken finger? I mean, what the hell? Traipsing around in French wigs in the Andes Mountains with all the Indians? Like, what the hell? Really? Well, but they still believe that Earth was a globe of some sort back then. And they still had an idea that Earth's radius was around 4,000 miles. So it gets even weirder. You got to go back to the 1600s. And you say, okay, did they get the radius value from something earlier that came before it? It turns out they claim to have done just that. There's a French guy in the 1600s. What was his name? His name wasn't Picard, was it? Like, all these Picards keep popping up. Was it Bruno? Anyway, the guy claims that he went from the center of Paris to a town north of Paris, which happens to be exactly like 69 statute miles, whatever they converted to in France that day. Today it'd be 69 statute miles. And he did a survey of the stars, and then he counted how many revolutions his wooden wagon wheel went along this road to the town 69 miles north. And then he measured the stars again and determined that the stars had rotated 1 degree for the 69 miles that his wagon wheel went by counting the revolutions on his wagon wheel. That's really the origin of the 69 to 1 rule, if you can believe that. I mean, you just have all these stories. You keep going back further and further and further. You eventually get to the golden seed value for the radius of the Earth, and it's fucking Eratosthenes, dude. And we already know the problems with that. He didn't actually measure the globe. He measured angular displacement over time, if that, of the sun. In a very limited part of the world, using very primitive methods. And the story may not even be true. Like, it really reads like a thought experiment. And there are many university articles written about this. Like, yeah, Eratosthenes probably wasn't a real guy, and this wasn't something that anybody had actually done. It was taught as a thought experiment through the schools back then, as you could do this conceivably. And if you do, here's what you might find. And the method isn't even exclusive to a globe, right? I mean, you have different assumptions, and he affirms a flat Earth, for crying out loud. So if they're really using this as a golden seed value for the radius and for all the things that followed, and let me tell you what, the kinds of things that followed, they're swinging pendulums all over the world, they claim. They're dropping plumb lines, and they're claiming to measure deviations. They would look at a star map, like a nautical almanac, right? And they'd wait for a star to come directly overhead at the appointed time that it's supposed to be. And the star's not there. And they're like, the star's actually a little bit over there. I wonder why that is. Must be gravity. A gravity field is warping the starlight, because the star must really be overhead, but I see it not really overhead. So if we just apply this curving gravity field, bada bing, bada boom, we got a globe again. Same thing happens with stars that are low on the horizon instead of directly overhead, except they don't use gravity to keep the ball going. They keep astronomical refraction on the table to keep the ball going. So just time after time, you've got all these ad hoc excuses. You've got all these methods that aren't globe exclusive at all. And all of this is being glued together into a gigantic ball of crap. And we're stuck with it. And you want to question some of this stuff, and people think you're crazy. I mean, they think you're crazy for looking into it in the first place. I keep forgetting I've got all my notes in front of me, but it's almost too much to go through, and I'd be sitting in silence while I'm scrolling. But yeah, what is fascinating though is how they do seem to claim that whatever gravity is, that the effects are different in different parts of the world just by a little bit. But what I find fascinating too is one of the original numbers for gravity was a transcendental number, which was pi squared. That's right, pi squared was used originally as the gravity acceleration is a constant. Yeah, and the square root of that's pi. But they would take these pendulums, right? So they would first get like a scalar quantity of gravity by taking the pendulum and swinging it and swinging it and swinging it, and they'd go somewhere and it would swing slower or swing faster. And they're like, okay, great, we got a difference here. We measured the scalar. Let's get a vector with this. And they would then take a plumb line and drop it. And it wouldn't drop and hang straight perfectly down, they'd say. It'd actually curve off to the left or to the right or forward or backwards a little bit. And say, aha, now we got a direction. So it's going to be pulling in this direction a little bit this way over here with this much strength over there. Write these numbers down. And it'd be like, oh yeah, this works great because guess what? We can explain this. It tends to happen around the base of all these mountain chains. Until they went to the fucking Himalayas and tried it, and it didn't work. That's right. There's a problem with the Himalayas. The gravity field, which they think should behave a certain way, doesn't behave that way over there. So it's not as consistent as they thought it was. And so they're like, well, fuck, it's an anomaly. We can't explain it. We got all these gravity anomalies everywhere. And even if you were to do this, it doesn't mean Earth is a globe, right? The problem, like I said, is they do this all over the world, and then they wrap it around the ball using a spherical coordinate system. Why? Because how did they log where they were? They used the coordinate reference system of the day, of the ages, which was inherently spherical. So they would bake in their location, their distance, and orientation from the get-go using that assumption. If they'd use something like the UK Ordnance Survey with the British National Grid System, where everything was surveyed flat and orthogonal instead of spherical, then you'd have a geoid that is more like a G flat. Like, you've got these crazy, funky pendulum and plumb line measurements all over the place that show variations, just not on a ball, but over a flat surface. So when the guy asked if I was cool with that, I'm like, yeah, I mean, fine. It doesn't change the shape of the Earth for me. And if there is some kind of anomaly, some kind of crazy field anomaly going on, then who's to say it has to do anything with an uneven distribution of mass through the Earth? What if it is the frickin' starlight, after all? What if when they hang the pendulum and they wait for the star to go overhead and it's not where they thought it would be, but somewhere else, slightly off, that it's because the star is not moving uniformly? It's funny. I even took I took some almanac data and shoved it into an LLM and had it crunch some numbers. And it showed me that the stars and their constellations actually moved with some very slight variability to it. Particularly low on the horizon, you get more distortion. That they even accelerate at different rates, and the rate of acceleration is itself changing very slightly. And the fact that it's not consistent tells me that it's not like some astronomical refraction going on. There's something else at play. I kind of think the star field above your head is lumpy, somewhat asymmetrical and a little lumpy. It's not the totally smooth mechanical motion that people think. And this could explain the geoid model. Nothing with mass attracting mass. It's already been mentioned a few times today, and it's probably mentioned a few times every day, that Friedrich Robert Helmert, F.R. Helmert, the German mathematician and surveyor who wrote Higher Geodesy, 2-volume set. It's a book. It's a book that you need to read. You need to find the English translation, unless you can do German, and just sit down and read it. Look, there's a lot of math, a lot of scary crap in there, a lot of scary calculus and trigonometry and stuff. That's okay. I mean, it's not necessary for you to like sit down and read that and try to figure out what is this trying to say. What's important is to read the narrative. It's actually quite refreshing to read what he's doing. He lays out very honestly and very simply what geodesy is about and how to do it. You can read for yourself that they measure Earth flat and then wrap it around a mathematical ball of their choosing, an arbitrary coordinate reference system. And when you apply that to today's technology, you've got these modern total stations that surveyors use. They got computers on them. You can set it up so that when you conduct your survey, that you're on a different coordinate system every time. You can choose a spherical one based off of WGS 84, WGS 83, NAD 27. All of these coordinate systems are going to give you different calculated distances between points and slightly different orientations too over time. You can even choose a state plane coordinate system that's flat, using flat coordinates, and give you flat distances. That's right. Just go in the computer settings, you select your reference datum, and off you go. And it's true to Helmert. Helmert says, yeah, you just got to choose a coordinate reference system that suits you best, suit to purpose, and apply this math or whatever corresponding math you need for that coordinate reference grid. And you can take your perfectly good flat Earth measurements and break them and twist them and bend them so that you can pretend that you live on a fucking globe. As long as you use it consistently, it's going to work, right? Works good enough. Why should you question it if it's working?
What do you guys talk about in here?
We challenged the idea that Earth is a globe in outer space.
And they ask us why this would make any difference in our lives.
Oh, that's, yeah. Well, space is fake. You guys don't have to worry about that anymore. I wish we were allowed to wear T-shirts at work, like with sayings and stuff. I would have one that just says "Space is fake." I know I'd be like walking around like I had the plague, but that's how it works.
You ever hear people say in the media like, "Oh my God, scientists think Earth might be speeding up," or "Oh my God, scientists think Earth might be slowing down in its rotation." You got this variability going on, right? You've got variability with the sun, just a little bit all the time. Same with the stars. It's not as perfect as globers like to think it is. Like I mentioned before, that smooth mechanical rotation, it really isn't like that, folks. People start to take notice of it and they write these articles.
What does it slow down and speed up?
Yeah, you ever read those articles like, "Oh my God, Earth is slowing down just a little bit this year"? I think it's because the sky rotation at night isn't as perfectly even and smooth as people like to believe it is. Slightly asymmetric here and there, and slightly, speeds up and slows down just very minutely here and there. And it may for some observers and not for other observers too. Depending where you are and what time of year it is, it's anomalous. Everything is anomalous. And the globe is created out of all the anomalies. The anomalies provide the room for people to accept the globe and to continue accepting it and reifying it year after year, age after age. You could pop up different planetarium software and they're going to give you different results, slightly off. It depends like which ephemeris they're working from. That's the other thing. Got all this ephemeral data from different sources gathered in different ways and they don't match. Just like all the different latitude longitudes don't match.
Is it public?
Yeah, I think a lot of these are, but maybe not all of them.
Like APIs I can go and build a table from?
Yeah, there's like the J2000 or something that people use, but it's not the only one. Yeah, man. So I grabbed data from one of these nautical almanacs. I don't know if you heard me. I shoved it into an LLM. This was like a year and a half ago. If Jedi's here, he remembers, and if I scroll up high enough in my DMs with him, he'll see it. But I started posting the output on the charts that it was spitting out, mapping the change of rate of acceleration of the stars between 0 and 90 degrees above the horizon over time throughout the year. And it wasn't uniform. Like the stars slightly accelerate and decelerate relative to each other, very so slightly. And it's probably different depending where you are and what time of year that you're going to be noticing
relative
this.
to each other.
Yeah, like the constellations aren't exactly always that way. Like they average out to look the way that you think they do, but the distance between them is not exactly always as uniform as you think. They're always going to be slightly a little bit off here and there.
So wouldn't that just be the same as why the sun is apparently in its location?
Yeah, I think so. And why it's all observer dependent in the first place. But I think that if you go to different places, you're going to see slightly different effects.
Yeah, but you still don't know if you're looking through something, which I think you are. You're looking through something.
Yeah, I think you are too. And that
And
something
that's
isn't
why
like a
you get an
uniform
apparent
medium.
location. That location moves between you and the actual source appears on the thing you're looking through. So that's an apparent location. The thing that you're looking at that's creating whatever, but that you only see on that surface isn't in that spot. It's somewhere else.
Yeah, and the medium could be lumpy, like could have some slight variance to its density.
Most more than likely it is. That's why you would see variances.
Right. And that's why they think that there's like lumpy gravity in the earth. They call it an uneven distribution of mass, but they're looking at stars to measure it. What if it's just a lumpy freaking sky, dude? Who knows? Maybe it's both. I don't care. Earth still measures flat.
Yeah, whatever is happening up there doesn't matter. I mean, whatever it
It's
does
cool as
is
shit,
doing.
though.
It's not going to change my house sitting on its foundation. It's not going to make it a different kind of ground underneath it.
That's for sure. It's not going to cause water to wrap around a ball.
You wake up and your whole street is curved. Like what happened?
Oh, fuck, I was wrong.
I was wrong. Look, it did turn into a ball. Damn.
Someone was saying in J.R. Tolkien's world that it used to be flat, but then like something happened and the universe broke and it got turned into a ball.
Yeah, it was called change this or you become a stuffed scarecrow in somebody's field. Oh, okay, I'll change it.
I got to go in a minute, but before I do, did you hear that the latest thing is Epstein was offered to purchase the Pentagon and other high security offices all over DC? Like,
what the fuck?
Somebody replied to this article I saw on Twitter, like, who the fuck is this guy? Is Epstein like a Nephilim or some shit?
Well, check this out. You know that the pentagram that Washington D.C. makes?
Yeah.
If you really look at that, everybody close your ears that's listening if you're on the live stream. Don't listen to what I said. I'm just making up stories for people to dream about. Anyway, that matches other Tartarian layouts.
Oh. Yeah.
Yeah, and then when I looked at a building in Cleveland, I realized the Terminal Tower, it was not made. That I took close-up pictures just with my phone. I was down there. That thing has got work I've never seen before. Griffins on the top, all that shit. So yeah, there's some other shit going on that we don't know about. That's where the real questions now start coming from.
Dude,
I don't care
when I
that
was
it's not
young,
a
I
ball.
used to.
I don't care that they pretended that it was a ball, and I don't care why. I now want to. Yeah, we took over buildings, found it in because
there's all kinds of strange shit
going
like that.
downtown in Cleveland, and I'm looking down this one street. It's in the flats. It's going way down to the river, and I'm looking at all these buildings. All their bottom windows are covered halfway. You have a window, and it's
like every town.
No, just halfway
every town in the freaking world.
Diagonally up the window, though. Like you built it purposely, finished that all off, and then covered it with dirt. I don't think so. I've never seen that done.
They claim it's years and years of like horses kicking up dirt in the street and just piling up further. Right? I'm like, yeah, right, dude. Or how they like
dries up and blows away. Most of us, or at least in Ohio,
you start like digging down underneath like a European town and discover an old Roman city. Like, how the fuck did that happen? You just like lose a Roman city and build on top of it. Nobody remembers.
So you better go look at that at what Washington D.C. That's why they said there's pictures of the Capitol being built when there's nothing around. It's not. It's another founded city. That's it. That's all. This shit's all been here. Okay, back to flat Earth. Yeah, don't. That was just a story. Don't believe anything I said. I'm a storyteller. Don't get all freaked out. But yeah, Tartaria appears to be real anyway. So you guys can have nightmares or whatever you want to do. Space aliens are fake. We're most likely the white people are the ones who came here and took over this place, and that's why we're pushing people around. That's what it looks like.
Yeah, when I was in Copenhagen, we were walking down the street, and if you look down the drains on the main street, you can see like the old front entrances to some of the buildings. When you look down the drain, there's like a door down there, like an old looking door.
It's
like
all
under the
over the place, dude. It's
yeah,
all
it's
over when
crazy.
you start looking for it.
I got a picture of it. I'll
So
try to find it.
when I was young, I used to live. We go so far off the beaten path and sometimes come across places where you'd see like random brick facades and stuff buried in deep into like rock faces. I remember like pointing it out and be like, what the heck is this? And my dad being like, it might be some old Spanish mine.
So I didn't
like
take
out in the middle of nowhere.
I might have a picture. I'll have to look from the other day. I'm looking at these buildings from the side on the street. The street's going down pretty good grade. I don't know, 15 degrees, something like that. And I'm looking and I see this one foundation and it's this gigantic barnstones. They are gigantic, making all the way around. And then built on top of that, it just gets cut off. And then on top of that is new red brick that goes around. And I said, oh, that's pretty funny. That whole building top is gone and they put a red brick building on top of that foundation and you can just see it's obvious.
Yeah, sounds about right. I see a lot of that in the town I live now where, the foundation looks like it was ancient and they just put a brick building on top.
So people are living in buildings that are still under the ground, it looks like. Like, it's like normal. Like you would think, oh, they built that down there and put windows there because windows should be down by the sewers.
Yeah, not like basement windows, but full
windows.
It's like, what, did they run out of money?
So the way that foundation on that building I saw, that was a bigger building than what I was looking at. And then as I'm starting to look at stuff, I noticed that there's a church over there. It says founded like 1870 something. That means that's when it was found. They're not lying with their wording.